Ladies and gentlemen, I'm Jessica Quinn, the Marketing Director at Cyber Defense Magazine, and I want to thank you for joining us for today's webinar presentation, The Top Application Security Trends of 2012, presented by Stellantis and IBIS Security. During today's session, you'll hear from two unique complementary perspectives on application security trends that have taken place throughout 2012, which will help you be better prepared for the upcoming year. First, our editor of Cyber Defense Magazine will share some of the key trends and his insights in the area of cloud computing and related network security breaches. Then, the CEO of IBIS Security will take you through some of the best insider information on in-the-field, boots-on-the-ground issues, such as top 10 vulnerabilities in cloud and web apps, top 10 business logic vulnerabilities, top 3 reasons why people were compromised, and much more. Finally, we'll open it up to Q&A and then share with you a special offer as promised. Allow me to introduce to you our speakers. Gary Milewski is a founding member of the U.S. Department of Homeland Security, has advised multiple U.S. President's cybersecurity teams, serves on the board of NASG.org, MITRE, and Norwich University Cyber Wars Research Lab. Akash Barai is the co-founder and CEO of IBIS and pioneer in cloud-based application penetration testing. He is credited of several innovations in the domain of network security and anti-spam technologies and has many patents filed. Akash is also an active speaker at various platforms like NASCOM, University of California, Berkeley, NUS Singapore, Global Security Challenge, TIE, and several others. And now, without further delay, here's our editor, Gary Milewski.
Jessica, thank you. Welcome to the presentation today, folks. We're really happy you're here with us. What I'd like to do is start it out just focused a little bit on, why is everybody moving to the cloud and are there risks? Now, software as a service model is great. Web applications moving to the cloud, wonderful. We've seen so many. We've got pressures from Amazon and Microsoft and others to get hosted on their cloud platforms. But has it become the #1 target of cybercrime? I believe it has. As Willie Sutton, the famous bank robber, said, why do I rob banks? Because that's where the money is. So the hackers, the cyber criminals, and the cyber terrorists are going to be gunning for your virtualized, web-based, and cloud-based applications because that's where the data is. So even today, there's a real growing epidemic of these security breaches. You can see a list of them on the screen. But I'll give you a few that happened this week. Adobe was hacked yet again this week. Nationwide Insurance Company, the famous company with the commercial Nationwide is on your side, was hacked. And they've had breaches this week. And Coca-Cola was breached in 2009, but they're only disclosing it this week. So there's so many breaches, either people know they've been breached, they're willing to disclose that they've been compromised, or they don't even know. And McAfee has some great statistics on that as well. So let's look at the current statistics. Cybercrime is up by 6% this year, according to the Ponemon Institute. If you just drive through the web, 30% of Google search results are drive-by malware-infected sites. Over 60% of Bing search results, now Bing is a much smaller search engine, but over 60% will lead to infected pages. Last month in October, the White House admitted they were hacked by China. In September, Adobe's update server was hacked. Microsoft Internet Explorer continues to be hacked. In fact, Microsoft released Windows 8, and in less than a week, Windows 8 has been hacked. Microsoft released 19 security patches this week, and 4 of them were for Windows 8 and Windows RT, which is a flavor of Windows 8 for tablet and phone platforms. Oracle released over 109 security fixes in October, so the stats are growing. If you go to a website called privacyrights.org, www.privacyrights.org, you'll see that there's over 563 million personally identifiable pieces of information records that were hacked, lost, stolen. So why does this keep happening? I've broken it down to what I would call the 7 worst practices in development of applications and as we move them to web, SaaS, and the cloud. Number 1 is poor coding practices, and we'll take a minute on a future slide you'll see to talk about poor coding practices leading to what we call common weaknesses and enumerations or software coding flaws. The third is network-based vulnerabilities. The minute you write code and you integrate with the RPC protocol or a flawed version of SSL, or you have a PHP script running or a Oracle database, MySQL or Microsoft database with flaws, then you end up with these network accessible hacking tools that you can download to break in. And so you have vulnerabilities and free tools. So holes with free tools leads to problems. Now, organized crime is now funding hackers. Why, go to the bank and hold up the person with a gun and bring some, C4 explosive to break open the vault when you can hire some talented hackers in other countries and get them to do your work for you online, over the web, hitting these SaaS, web, and cloud-based applications. And finally, we see a lot of governments attacking each other. We see cyber espionage on the rise, and even in the recent James Bond movie, they probably moved the theme of these kinds of films to, why run around as an old-fashioned spy when you can hire a cyber hacker to do the espionage for you? So state-funded cyber warfare is huge, and the lack of regular assessments and remediation. Let me go through this last one for a moment. I think this is the most critical. Do you penetration test your SaaS, web, or cloud application? And do you report on the holes and strategize how to fix them? Do you schedule workflow and perform remediation? Do you understand how to harden systems and remove holes? And if you don't, then you're in trouble. So you have to do these things, and you have to repeat them over and over. We're going to learn from Vikash the best times to do it, how often to do it as we move forward. But these are some serious questions I have as we move forward on this concept of moving to the cloud. Is it safe? So if you've written code poorly, and please write this down, folks who are attending, cwe.mitre.org has a full framework on common weaknesses and enumerations on how people break into code. So if you wrote code with one of these top 25 flaws that I'm listing on the screen here today, I think we made it to the top 21. Didn't fit them all on the screen, but look at all these models of writing code: incorrect authorization, not having integrity checks, the typical buffer overflow. These are the common problems in code development that lead to common vulnerability. So there's a one-to-one correlation. If you have poor coding practice, you will end up with a network approachable vulnerability. Let's go to the next slide and we'll learn a little bit more about these network-based holes. These are called common vulnerabilities and exposures, or CVEs. And if you're not penetration testing, then you don't know if you have CVEs in your cloud-based applications. So check out cve.mitre.org. And let's take a look. Here are some of the worst exploitable holes. This week, Apache chunked encoding memory flaw. So there was a flaw in how they wrote their code, and they have an error that is now remotely exploitable. Microsoft had some holes in ASP. They had some holes in the Windows Server code. And, of course, the Remote Desktop Protocol, or RPC, underneath the Remote Desktop Protocol, is susceptible to remote exploitation as recent as this month. So bad coding practices leads to vulnerabilities that are remotely exploitable, and so we continue to patch and pray. There's got to be a better way. Let's go to the next slide. So, is it worth moving to the cloud or going SaaS or web? Well, I think it is. I'd like to cover some of the benefits on demand. So think about it. There's no capacity issue. If you need 1,000 servers running, Amazon's got 1,000 waiting for you, or other cloud providers. Microsoft, Google, Amazon, others, Rackspace. So there's all the space in the world for your applications to run to cover all your end user demand. There's a lower cost to this because you don't have to worry about new rack servers, new hardware, upgrades, new operating systems. Even the patching of some of these systems that are the underlying cloud hosts are going to be taken care of for you. That doesn't provide you security, but that gives you a stable, growing environment to run your applications. Now, the rent versus own model is excellent. Think about the elasticity of the cloud. If today you have 1,000 customers, and if tomorrow you have 10,000, don't worry about it. You're renting space that can shrink or grow automatically. And of course, you get space and time savings. See, updates are faster, so you can deploy quicker. You're deploying in one location and it's virtualized across many. This should give you more reliability as well. And the cloud providers are guaranteeing to some degree that, yes, they put some diesel fuel in the diesel generator for business continuity and disaster recovery, etc., but also you want to make sure you have a good service level agreement. Most of the cloud providers will give you the reliability you feel you need, but again, they're not guaranteeing security, and that's what we're here today to talk about. Finally, 724 365 access worldwide to your apps makes you a global presence pretty quickly at a low cost. So you're getting a year-round 24-hour system in place. These, I think, are the reasons why I consider moving. But hold on a minute. When we move, these are the questions I have, and I ponder as someone in the field and as the editor of Cyber Defense Magazine, where I hear about all the breaches daily. So the questions I have are, what are the most critical vulnerabilities that threaten the security of my perimeter defenses on the web or in the cloud? This is really important. Do I have holes that are breachable? And what's the probability that a cyber criminal could penetrate my SaaS or web-based application and gain access to my data, as Nationwide learned this week, or Adobe learned yet again this week, or Microsoft? And how can I find my own vulnerabilities and do it in a way that doesn't waste a lot of time with false positives and problems that a lot of us deal with on a daily basis? If I'm really going to take this seriously, to harden my SaaS or cloud app or web application, how do I get at the vulnerabilities that are real and not have any false positives? And finally, how do I prioritize those vulnerabilities? Which ones really matter so I can create a plan on how to improve this problem I have and get the budget approved? Maybe I need more IT staff or some experts or some help from third parties. So how do I do that? Let's ask Vikash Barai, the CEO and co-founder of iViz Security, as he takes us through the answers on a deep dive.
Great. Thank you, Gary. Thanks a lot. So what I would do is I'm going to deep dive a little bit from the perspective of our experience in terms of conducting more than 5,000 tests last year for our different customers. We focus more on application security testing. So I'll present to you today a bit of this original research from the data which we collected from this 5,000 tests which we conducted. And I will also share some of the experiences which we have, some of those findings which we have. And I believe some of these would be unique and quite interesting. So before I get into that, very quickly about iViz, we provide cloud-based application penetration testing. So we are probably one of the first companies to take penetration testing or ethical hacking to the cloud. And unlike the other products which are there in the market, we guarantee zero false positive. We also do the business logic testing with 100% WAS class coverage. Funded by IDG Ventures, we discovered more than 30 zero-day vulnerabilities, like we broke Microsoft BitLocker's encryption, we broke McAfee SafeBoot, Intel, HP, Lenovo's BIOS security. We broke some product or the other of all good security companies, whether it's McAfee or Symantec. And we got a lot of recognitions as well, like Gartner recently put us into the hype cycle. In fact, in 2 of their hype cycles, security as a service as well as dynamic application security testing. So let me quickly tell you about the methodology of the research. So basically, we tried to collect the data of this 5,000 application security tests which we conducted, what kind of vulnerabilities we found, what are the kind of threats which we observed from our 300 plus customers, and we tried to capture that entire thing into something which could help you guys to prioritize your application security strategy. And a quick breakup on the geography. In terms of geography, 25% of the applications were from Asia, 40% were from US, and 25% were from Europe. So some of the key findings. So from the experience which we had, we saw that 99% of the applications which we tested had at least one vulnerability. It's like almost 100%. So almost any application out there is going to have one vulnerability or the other. And out of them, 82% of the applications which we tested had at least one high or critical vulnerability. Now that's something quite scary as well as interesting. Then we help a lot of customers who at times get compromised and then come and get in touch with us. So we help people to recover from these hacking incidents, and what we saw is that 90% of the hacking incidents never gets known to the public. These are all data based on our sample set, so it may vary from some other figures which you may have seen. Then another very interesting thing which we did is that we tried to find out the average number of vulnerabilities or the security of the different applications of the compliant organizations, that is the organizations having some kind of compliance and the organizations not having compliance. And what we saw was that there's very low correlation. So we have the correlation coefficient of 0.2, where if ideally correlation coefficient was 1, that would have meant like there's perfect correlation. So compliance, as all of you would agree, doesn't necessarily mean security. Our data point proves that once more. The average number of vulnerabilities which we discovered in the different websites were 35. Now, this is one number where you may find some difference with some of the statistics presented by some other tools. Like there are different other tools where you will see that they project a number which is as high as greater than 200. So our number is quite less compared to 200. The reason probably are, one is we assure that we remove all false positives. So we provide this zero false positive guarantee. So the tools cannot do that. So that could be one. The other reason could be that the way we report a vulnerability is that if there is one cross-site scripting vulnerability, and if that vulnerability gets manifested in 100 pages, and if the root cause is just one, then we still identify that as a single vulnerability. Whereas the tools, whichever tools you use, they will show it as 100 vulnerabilities. So since we do a root cause analysis, probably that's the reason why the number went down. And so I think these are the probable two reasons why our number differs significantly from the numbers which are published by other tools. That is because we remove false positives and because we do this root cause analysis, and many a times 100 vulnerabilities may have a single root cause. Now back to the next point, we have seen that 30% of the organizations who got hacked, they actually knew about the vulnerability, or at least some person in their organization knew about the vulnerability because of which they got hacked. So they somehow couldn't fix it, or they didn't prioritize that. The other thing is that the number one vulnerability which we saw the most frequently occurring is cross-site scripting. The most secure vertical which we saw, industry vertical, have been banking, and they have significantly less vulnerability density compared to any other verticals. And the most vulnerable vertical which we found was retail. So here is the average number of vulnerabilities which we saw. the large websites, we try to classify this into 3 buckets, because if we would have provided you just a simple average, many a times we won't be able to kind of benchmark that in the right manner. So the large websites, we saw that they on an average had 78 vulnerabilities, the medium size 35, and the smaller size had 26. Then we also again classified these organizations into high security organizations, that is organizations with high level of maturity, the average security, and the below average security. And between these 3 classes or groups, we saw that the high security organizations had 22 vulnerabilities, average 41, and below average as 81. Now these are the top 5 application flaws. So we saw that 65% of the applications which we tested had a cross-site scripting vulnerability, 51% information leakage, 31% content spoofing, and 25% had cross-site request forgery. Now this is something interesting. What we noticed is that even though the applications are tested, many times people just run a scanner and get a test done, and they attain some level of security. What we saw is, based on our experience, that the most significant impact in terms of negative impact which the vulnerabilities had, if we just classify those vulnerabilities, the vulnerabilities with maximum negative impact, we saw that most of them belong to the business logic class. So we can have 2 types of vulnerabilities. One type of vulnerability are because the coder coded it wrongly. But then there could be also another type of vulnerability which is because of wrong design, because of wrong business process design. So the coding or the implementation may be okay as per the design, but the process itself has got a flaw. So I'll give you some examples. These are kind of 5 common business logic flaws which we observe, and there are many more. And in fact, at IVIS, when we conduct the testing, we have the 0 false positive guarantee, but the second, another most important point which we stress on is the business logic testing. So a few of the examples are like weak password recovery. So many of the password recovery processes have the way it is designed. You will see that the questions which are asked during the password recovery process are the sample answers for that could be very limited. I'm not talking about the big and the most prominent guys, but many of the other applications which are designed by the normal businesses, not the typical online giants. The password recovery process is such that you can easily guess some of those answers, or if you try 7 or 8 guesses, you can do that. So even though the recovery process is there are ways to brute force. That's one. The second thing is, like, many a times these websites allow you to reset the password directly, and it doesn't need you to log into your registered email account. So we see this kind of flaws very frequently in applications which are not from the most commonly known players. Then this is a very interesting one, which is abusing the discount logic. Now, this is something very common. Many of these online shopping websites have this business logic issue, and many of you can actually go and buy a lot of things free of cost. So one typical example is like you can use the same coupon multiple times during the same transaction. So somehow the logic behind doesn't check whether you are using the same coupon or not. And you actually can then get discount more than you are supposed to. If it is a 10% discount coupon, you can use it like 10 times during the same transaction. Then you can also manipulate certain values while the data is in transit. So these are certain other vulnerabilities which are there. There's another common vulnerability which we have observed is the denial of service. Like, for example, many of these flight booking systems got this vulnerability. Like, you can actually create some 100 threads, and each of these threads are trying to book a particular book a flight ticket. And while doing that, what happens is that the system behind don't allow the other users to book the tickets in parallel. So by creating a lot of these parallel threads, you can actually make the system cause denial of service to legitimate users. Then there is this price manipulation vulnerability, which we have seen very frequently. So this is because of lack of authentication between the payment gateway and the application. So while the data is being sent to the payment gateway, you can actually manipulate the value. So what happens is that the information goes to the application that the payment has happened, but the amount of payment gets modified while in transit to the payment gateway. So you pay less and yet you get what you wanted to buy. So this is another very common vulnerability which we see. There are certain other, the fifth one which I would like to discuss is insufficient server-side validation. So I'll give you one example of that, and this is one which we recently conducted for one of the banking systems. It's the one-time password bypass. So what was happening was that the system was sending the one-time password to your mobile, and at the same time it was sending the one-time password which it sent to the mobile to the browser so that it could validate the OTP at the client side. So now the client side validation function got the OTP. So the moment you reverse it, you actually get the OTP. And interestingly, they just kept it in plain text. There are some people who use some kind of encoding, but then even you can break the encoding. So there's a lot of such flaws or business logic flaws which we see because of a lot of logic being passed on to the client side and insufficient server-side validation. So these are some of the examples of business logic vulnerabilities. So then we wanted to see which are the most vulnerable industry verticals and what's the vulnerability density of the applications in these different segments. And this is quite interesting, though not something which is not impossible to guess, but interestingly, retail kind of tops the list. 56 is the vulnerability density. Then comes education, IT, healthcare, then the telcos, manufacturing, and the banking. Now there are some elements over here which could be a little bit surprising, like the manufacturing is the most secure vertical after banking. So I can't really vouch for that because this is a very startling fact which came out of our research data. The reason why probably we saw this is the customers who come to us, the manufacturing customers who come to us are probably the ones who are very sensitive towards security. There are a lot of manufacturing companies who are probably not testing and their security could be absolutely bad. But the ones who come to us for testing, they are probably more security sensitive. So that could be one reason. The other reason could be that the manufacturing applications are less complex. Like the retail applications are very complex. In manufacturing, they have hundreds of applications which are smaller and less complex. So that could be another reason. So when you see this information, I mean, this is based on the data which we have and may not necessarily mean that manufacturing is the next most secure vertical or retail is the most insecure vertical. But generally speaking, I believe this is correct. Then we wanted to actually just check out what's the vulnerability density of the applications in the different geographies. So we more or less saw a similar kind of vulnerability density, though United States had lesser, the applications from US had lesser vulnerabilities than in APAC. So probably the reason could be that the adoption of the security technologies happened faster in US and then in Europe and then Asia Pacific. So the next thing which I wanted to talk about is the top 5 application security trends. So these are the 5 things which I believe from my experience in terms of working with our customers, conducting the testing, talking with different analysts, talking with the industry peers, the other technologists from different companies. So this is a culmination of ideas and thoughts from all these different sources, and I picked up the top 5 application security trends which you shouldn't miss. I mean, these are the ones which are extremely important today or are going to be extremely important today. So one of these things is runtime application security protection. So today, if you see, the way we protect an application is mostly external. I mean, it's more kind of reactive than proactive. And most of the applications internally don't have the kind of security protection. If you look at the operating system went through this kind of long time back. The initial operating system didn't have so much of security inbuilt, and then gradually the OS started having a lot of these mechanisms to stop the buffer overflows and things like that. And I strongly believe the same thing is going to happen to the applications, and the way is probably runtime application security protection. So runtime application security protection is the mechanism where the application can intelligently, during the runtime, determine that it is being attacked, that something malicious is happening. So you don't rely on the web application firewall. You don't rely on penetration testing. The application itself is intelligent. So the runtime application security protection can detect attacks at the runtime, and not just detect the attack based on the different behavior pattern, but also it can take a decision to terminate a session. It can raise alerts. So this is going to be the next generation application where the application itself will have the self-protection. And we already have some solutions, but this is in a little bit of nascent stage in terms of not just technology, but also in terms of adoption. But definitely this is something which is going to be very interesting. And runtime application security protection can actually interact with web application firewall to verify or to take actions, etc. The next, number 2, though this is not in order, I just kept like all these 5 trends as separate 5 trends. I didn't try to order them. The next trend which I'll talk about is collaborative security intelligence. So again, if you look at the kind of transition which has happened to other security verticals, other security technologies, there had always been convergence. Like, for example, we started with things like antivirus, but today we got endpoint security protection. So lots of things getting combined. So this is a general trend which happens. Like, you have multiple technologies, but then they converge. They learn how to talk to each other, and they can collaborate, and they have a intelligence layer on top of it. And the same thing is going to happen to, or is happening to, the application security industry. One of the good example is dynamic application security testing being combined with static application security testing. And as many of you are aware of, that in the dynamic security testing, you don't need the code. So you can just test the application without having the code, whereas for static, you need the code. So by combining dynamic and static, you can actually remove false positive. And not just that, you can actually pinpoint to which part of the code the flaw is. So as of today, the dynamic application security testing is a lot easier to adopt, and I believe that's the thing which an organization should do as the first step, because that's what a hacker is going to do. A hacker is not going to have your code. So the low-hanging fruit is dynamic application security testing, and that's the reason why the adoption of DAST is probably 3 to 4 times higher than SAST, but it's going to get combined. Then you can actually combine DAST and SAST with web application firewall. So imagine the vulnerabilities which are being discovered are fed into the web application firewall, so that the web application firewall can now design rules to stop certain kind of attacks. Again, this is there, people are adopting. The other thing is you combine SaaS, BAST, and web application firewall along with incident management. So now you feed this information to the incident management system along with the web application firewall. So basically what we can see is like these multiple systems start talking to each other, and they can collaborate better, and they can take decisions which are a lot more meaningful and reduce false positive, etc. And someday this is hopefully someday will arrive where we'll see a grand unification, like in physics. I mean, as many of you are aware of, grand unification theory is one of the most elusive theory which all the physicists are running after, which Einstein tried but failed. Today everybody is running after. And someday we would probably see a grand unification or something near to grand unification where all these different security products can talk to each other and take intelligent decisions. The third thing which I would like to talk about is hybrid application security testing. So today, if you see the way testing happens, we either take a BAST tool or a SaaS tool and we conduct the testing. But obviously all these tools have a problem, not a problem, many problems. One is definitely false positives, so you need to manually remove those false positives. The other is business logic testing. These tools can't do business logic testing. So these are the problems with automation. So the question is, why can't we solve these problems using artificial intelligence? Why is AI not enough? And AI is something which is very near to my heart. In fact, my background is AI, though today I focus more on business. It's one of my passions. So few reasons why probably we can't do that is, like, one is multi-stage attack planning. Like when I, as a hacker, when I'm trying to break into a system, I'm doing attack chaining. I'm using one attack, then chaining it with another, doing privilege escalation, moving on, and stuff like that. So the moment you want to do this multi-stage attack planning, and this is one problem on which we worked at IBIS, and in fact we got an award from Intel and University of California, Berkeley, because of the technology which we developed to simulate multi-stage attack planning. So what we built was something like what Expedia did to travel planning, we did the same to attack planning. But then, even though we did it, the fact of the matter is that this kind of problem is p-space complete problem. So the moment the number of nodes get increased, you run out of space, and even the supercomputers won't have enough space to solve the complexity of a decent-sized network. We tried to do some approximation and we solved it to some extent, but if you want to solve it 100%, it's not feasible as of today. Modeling creativity. We human beings are creative. There are AI models to kind of simulate creativity or intuition, but then those are very suboptimal. Those are not yet enough to kind of match a human hacker. And the other point, which is very important, humans can question assumptions. Like, the moment we look into a problem, like, for example, when we look at the physics, like, Newton came up with classical mechanics, but then Einstein came up and said, like, when the mass becomes very huge, these rules don't work anymore. So he questioned the assumptions and he came up with the theory of relativity. And then Heisenberg, he came up with things which again challenged both Newton as well as Einstein, and that for extremely small particles, none of these rules work. So humans can question assumptions, whereas the tools or the programs are built upon assumptions. So AI probably won't be able to solve this problem very easily, at least not in distant future. So how to solve them? So the question is not about man versus machine, but the question of man and machine. And hybrid testing, which is combination of human testing and human-based testing and automated testing, is probably the solution. But then it's not in the way consultant does, because if you look at the number of websites which are there, just the websites, not the internal application, just the websites are some 650 million globally. We don't have enough humans, forget technology people. We don't have enough humans to test all these websites on a regular basis. So when I talk about hybrid testing, it's not just getting consultants to do this testing. It's going to be an intelligent way to combine the human augmentation along with automation. At ISIS, we try to do some of those. We try to build a kind of process where maybe a good analogy would be like what Ford did to the manufacturing industry. They came up with this with the assembly line, and with the assembly line, they brought down the cost of manufacturing cars by 1/10, increased the wages by twice. So changing the way the penetration testing happens. So you still need to have the humans, but you need to change the way things are done. So that's what I mean as hybrid testing. So I believe this is extremely critical for us to have the ability to conduct testing for all these websites which are there online, all these internal applications which are critical. The next one is application security as a service. And many of you who read the Gartner reports, you will see that this is one of the top trends which Gartner is predicting. And it's very obvious. And it's very obvious because of a very simple reason, that there's a difference between what we need and what we want. And if we look at what we fundamentally need is service. We don't want tools. We just want solution. If there was a magical person who could solve all these problems using magic or voodoo, we don't care. We just want the solution. So that means we want service. So it's a very obvious thing that this is just like cloud or SaaS. This is very obvious that is going to be adopted in a big way. Though I believe both products and SaaS are going to coexist, but the way products dominate today is absolutely going to go away, and maybe someday SaaS is going to dominate. So the biggest problem which the AppSec industry is facing today is getting the right kind of people. That's the number one challenge which they're facing. And the overall trend is obviously going to cloud, getting it done rather than doing it yourself. So the different options which you can leverage are going to be web application firewall as a service, security incident management as a service, the dynamic application security testing or vulnerability management as a service. This is the space where we operate in, but there are so many players who are coming up in this space. You should definitely evaluate all these players. And the hybrid penetration testing as a service, that's the area basically where we focus in. In terms of the benefits, quite obviously going to application security as a service would be solving the problem of people, reduction of the operational cost, and the management overhead, and of course helping us to focus on our core competency. The last of the five key trends which I see right now is moving beyond secure SDLC and moving to DevOps. So today, if you are into the development field, you will see that due to Agile and many of these modern software development methodology, the focus is more on communication, collaboration, and integration between developers and IT operations, because the pressure is on how you can get the release faster. People want 15-day release cycle. So DevOps has become extremely pertinent today. And hence, it's very important that we look beyond secure SDLC and we look into how we make the DevOps process secure. And the way we implement secure SDLC and the way we are going to do secure DevOps is going to be a little bit different. Though there would be a kind of common overlap, there would be a lot of elements which are going to be unique. So this is going to be the future. In future, we are going to probably talk about secure DevOps and not secure SDLC. So I'll quickly talk about application security vulnerability management model, which we thought, which we saw from our experience could be helpful when you have huge number of applications. So number one step is to actually classify your applications, like how many are business critical, how many have low business criticality, how many got medium business criticality. So this is one very important thing. And interestingly, there are not too many organizations who know all the applications who have, like large I remember in one of the conference, the speaker asked, like, how many of you know how many apps do you have? Very few people raised their hands. And then we need to have different ways to tackle these three different kinds of applications. So we try to look at the testing part, and then we'll come to the other areas which you need to look into. So first I'll cover the testing. So when it comes to the testing, it's very important that we classify the type of testing into three different ways, in three different buckets. So one is the automated testing. Obviously, they are poor quality. The other is, we call them standard, where we have automated testing, but we remove the false positive. The third is automated testing plus false positive removal plus business logic testing. So these are the three types. Now let's look into the strategy. So for the applications which have high business criticality, we should do this premium testing with business logic testing and false positive removal during every major release, and maybe do the false positive remove testing for every minor release. For the medium business critical applications, you can just do the standard testing during every release. And the low business critical applications, you can probably just deal with automated testing on a quarterly or even yearly or maybe during every release. So classifying your applications and treating them differently is very, very critical to optimize your budget and also fix them at the right time and have lot better security posture. So basically, 80-20 rule applies as usual in this situation as well. And based on 80-20 rule, we try to map the top 5 things which you should do to secure your application or to have a robust application security strategy. So number 1 definitely is identify and classify all your applications and figure out who the owners are. Number 2, conduct the regular testing. I discussed about that. Number 3, implement an efficient patching process. And this is a fundamental roadblock. We have seen lots of organizations can do the testing, but they're not able to fix it. So you need to revector or reprioritize so that you can take a lot of your energy and bandwidth and put it into the patching process so that the pipeline can be maintained in the right manner. The number 4 is implementing web application firewall for the business critical applications. You may not need it for all, but for the business critical application is a great thing to do. And the number 5 is implementing a secure SDLC or a secure DevOps so that your development process is secure. So that's all from my side, and Gary or the audience, if you have any question, maybe we can address those.
Vikas, that was very informative. You've answered some of my questions. I do have a few more remaining, and I'm sure folks in the audience want to participate. So there is a Q&A section here. It's kind of like the chat window, but you can actually type a question in, ask a panelist, Vikas or myself, or both of us, and we'll get you an answer. While you're thinking about your questions and looking at the Q&A section in WebEx, Vikas, let me ask you a couple of questions just to get the juices flowing. My first one is really about secrets. You guys have some secrets. So what are the secrets that vendors in this market of application penetration testing don't like to share?
Okay, that's a tricky question. I didn't know you will ask me this. So I believe it's not just the penetration testing segment, but security in general. I mean, this is a segment where people try to sell using the FUD factor. They try to spread the fear, uncertainty, and doubt. So, and many times the sales guys, they are not fully aware of the technology, and in fact, security is complex. So there's a lot of kind of secrets or lies, maybe what you can say. So a few which comes to my mind would be, like for the penetration testing, there are lots of vendors who may claim like this is 100% safe. I mean, we have 100% safe testing. Technically, it's infeasible to have 100% safe testing because you can always have an application where it is coded in such a poor manner that just by sending some request you can create a DOS. So, Gary, I don't know if there's some echo. Maybe if you could help with that, go on a mute or something. So, so back to like 100% safe testing. This is something which is probably technically infeasible to do. So you can do safe testing, but you can't guarantee 100% safety. The other thing which I'm seeing a lot these days, not related to penetration testing domain, but everybody is coming up with a solution for APT. Advanced Persistent Threat is the tool using which everybody is pushing solutions to sell in the market. So truly speaking, from my experience in terms of breaking all this, like our team's experience in terms of breaking all these products, best of the breed security products, etc., having very we closely observed this particular industry and how hackers work, etc., and having the knowledge of that firsthand, what I can tell you, this is a lot of fun factor. And many a times APT in the sense it's not advanced. I mean, it's more persistent than advanced. Only a few could be advanced, and those which are advanced are something which had already been known to the best of the guys before. It's not that something has changed all of a sudden. So nothing got advanced all of a sudden. It's the same old thing growing or becoming mature in the same pace as any technology matures. Okay, it's just that the adoption of cyber warfare, etc., is becoming higher, but that happens in any other field. So APT is probably more persistent than advanced, and people try to sell everything using APT, and there's a lot of lies which happen in this APT. So these are some of the things which comes to my mind, but this is a great question. Maybe someday I would like to write a blog on like top 5 lies of application security vendors or something like that. So thanks, Gary, for asking that question.
Okay, Deb asks us a question which I'm going to answer out loud and also in the question and answer section. She asked for me to repeat the name of the Privacy Rights website, so I'm sending that out. It's privacyrights.org. And also there's another really good one called DataLossDB. They both share the information in a slightly different way, but they're up to date almost daily. Now, folks, if you're going to look at DataLossDB, please Google it and find the right one. The .org or the .com, I'm not sure, but one of them has zero-day malware on their webpage. Privacyrights.org is fine. DataLossDB, if we find the right page, is good, but I forgot which one it is. And Vikash, back to you. You were giving some great kind of secrets and insights, kind of the dirt in the industry. So with that information, what would the best way be to evaluate a security testing vendor?
Okay. And Gary, I mean, while you were asking me this question, another thing that came to my mind, and it's a funny answer to your last question. That's one of the lies which vendors say, and that is like, we don't have any false positive. Okay, by the way, that's what we claim. Huh? So that could be a very ironic kind of statement, but let me explain. So the reason why we claim zero false positive is because we do manual validation. So if there's a product which says zero false positive, there's a high chance, and if they're not doing manual validation, it's again an infeasibility. In fact, even with manual validation, there's some chances at times you can't really determine whether it's false positive or not. So now this is another tricky thing, though it's very much related to ours. Our claim. So I'd like to point that out, that you can probably guarantee zero false positive only when you do manual validation like the way we do. But otherwise, just with pure automation, you can't do that. And if you do that, you would have a lot of false negatives. So you'll miss out a lot of vulnerabilities. So now back to this second question which you asked, Gary. How to evaluate a penetration testing vendor. So a few things that comes to my mind, and maybe I'll not be able to cover all of them. So one would be the quality of results. So what's the kind of SLA they're providing you in terms of false positive or false negatives? Are they doing business logic testing? Is there some benchmarking? So false positive, false negatives, and business logic testing, one very important part. And how do they kind of assure what they assure? What's the testing process? It's very important to know the testing process. And if you are using a consultant, then it's very important to know the person. Who is going to conduct the testing? What's the background? And how many days is that person going to spend for the testing, etc. So the people behind the testing is very important. Though at ISIS, what we have done is we have made process more important. The way we do testing is fundamentally different. I mean, we have done something like what Ford did to the manufacturing industry. But then if you're just going to a normal consultant, people would be the most important. Then what is very important during the evaluation process is though it's not related directly to the vendor, but it's related to your strategy. It's of no use if you do a great testing once in a year. You should do testing during every major release. So whoever you are choosing or whatever strategy you are adopting, does that let you conduct frequent testing? That's very important. So while you evaluate a vendor, you should see, can the vendor help you to test on a regular basis, or does that model help you to test on a regular basis? Doing once a year testing is almost of no use. So it's rather better to do like low quality tests on a lot more frequent basis and a high quality testing just once in a year. So frequency is the other. Then the other factor is like conducting the test during the off business hour, if that's a part of your business requirements, checking that out. The other part is the security policy of the vendor. It's very important that you know how secure the vendor is. What's the security policy? How do they store the data? Do they keep the data in the laptop? Are they storing it in the cloud? In case what's the policy? How do they handle that? Then doing some background check of the individuals. If it's consulting kind of model, then that's very important. Your options to delete data. So I'm thinking of actually, I'll send one of these checklists to all the participants soon, where you can actually save this time of creating a checklist yourself, and you can just score the different options which you have and select the one whom you find more suitable. So I'll try to send you guys a nice checklist to measure this. And by the way, there's a blog which talks about this, but it's not in form of a checklist.
Vikash, that sounds great. We have 3 more questions from participants. The first comes from Ken. Ken says, isn't a false negative much more critical than a false positive from a security perspective?
Oh, Ken, that's a fantastic question. I mean, it's a wonderful question. I fully agree with you. That false negative, if that false negative is a critical one, if you have missed a vulnerability which is just an information disclosure which doesn't impact significantly, then it's not a problem. But a false negative which is critical is obviously more important. That's true. But the number 2 factor is that false positives are very costly. What happens is, like imagine you are the guy who is going to fix the vulnerability, and you get a report which got 200 vulnerabilities, and out of which you see that 100 are false positives. So you will have to manually remove those false positives. So what it means is that you got to hire somebody to remove the false positive. And just to give you some idea, that if you buy a tool from the market, like a good tool from IBM or HP, and you spend like some $50,000 to $100,000, you need to hire another 1 or 2 guys in your team. So you end up spending like $150,000 to $250,000 because you got to remove this false positive. Without removing that, you can't give it to the guys to fix. So false positives are very costly, but false negatives are extremely important, and it could be costly in a different way. So you need to have a strategy which optimizes. So at IBIS, what we have done is that we assure false positives so that you don't need to hire people to remove them, but at the same time, we cover all the WAS class, 100% of the WAS classes. That is, we take care of the false negatives, which the tools the vulnerabilities which the tools cannot find out, we figure that out. And the way we do it is like we got a 3-stage testing process. First stage is the automated testing. The second stage is automated plus manual, which is the false positive removal. The third stage is again automated plus manual for the business logic testing. And in this third phase, we take care of the false negatives. So we got a like staged approach to remove false positive, but that's in phase 2. But in phase 3, we also reduce false negative. So whatever strategy you have, whether it's internal or getting solution from outside, you need to focus on both. Like you need to address the problem of both false positive and false negative.
Excellent. Now, Vikash, we're coming down to the last couple minutes, and I know attendees are hanging on to get some of those offers that you promised. So let me give you 2 quick questions from Sandeep, and I have one more of my own if we have time. You just had me thinking about all this. First, let's take Sandeep. He had 2 questions. One is, can IBIS test and secure data in flight? i.e. transmission of data within the cloud infrastructure prior to it entering a WAN environment? That's his first question.
Okay. We can test, but can we secure? We can secure in terms of providing you a strategy on how to fix, but we can't. We are not a protection technology. We are a proactive testing technology. So we can test, and the way we can test is that. So basically, for data in motion, I believe that's your question. So the vulnerabilities which we see for data in transit or data in motion is or are related to the protocols which you are using. So sometimes the protocol is such that you can do manipulation, you can do man-in-the-middle attacks. Like for example, one of the vulnerabilities which I talked about, that is the price manipulation. So we actually change the data in transit. Okay, so there are some open source tools also which allows you to conduct such kind of testing, but of course they have limitations. So the answer is yes, and we can do that, but this is quite a deep topic. Some of the ways would obviously be looking at the protocol, doing protocol causing, trying to check you can manipulate data or not, etc. But if you want more in-depth information, I can actually send you a more detailed kind of white paper or something which I have.
Now, Vikash, that's a great answer. So testing, yes, but securing in transit, it's really more about a strategy and maybe other tools as well. Sandeep had another question. What are the trends to deliver security in the cloud and the VM level, particularly adjacent VM security?
Okay. Now, truly speaking, I'm not a VM expert, so I would probably pass on this question. But what I can do is our CTO, he would be the right person to answer this. So I could have given you an answer, but that would be very broad level, since VM is not my specialization. But there are some fundamental things which you need to do, which is like the testing, etc., the VM hardening and stuff like that. But then I'm not an expert of VM.
That's actually a good short answer. I think that from my perspective, does your VM provider have a regular security fix process, and do they put on their website what the vulnerabilities are in their VM? For example, VMware had 9 common vulnerabilities and exposures in the past few months that they've patched or fixed, and does your cloud provider fix that for you as your host? I would even include that in my SLA. I'd say in my service level agreement, ensure the hypervisor and the VM is as secure as you can possibly do in sync with the manufacturer of the software or system. That would be our last question from the attendees. I know you have one or two more slides, or a slide with how they can get a free penetration test. I have one quick question, if folks have time. It's really, I really wanted to understand what's a real recent kind of a happen in the real life case study of an organization that you think is a good example that you'd want to share with attendees, kind of like a blueprint for them, because we have attendees in banking and retail and different markets. So give us a quick kind of overview of something that went really successful, or a case study of an organization that you'd say you'd want to share with others as a good example. And we'll bring it to close after that answer.
Okay. So since we have very little time, what I'll do is I'll touch upon this very quickly. So one of the organizations which actually impressed me in terms of their security strategy, I would say would be Cisco. So I was talking with one of the key persons from the Cisco security team. I'm not divulging their name because I don't know whether they would be happy that I praise them. But then Cisco had a very nice practice. Many of our customers also have very nice practice. But I won't be able to tell you exactly the strategy of a particular organization. But then what I could do is I could talk about some of the fundamentals, which would be like taking those nuggets from all the different organizations. So fundamentally, it's like going back to my slide of the 80-20 rule, those top 5 things which you need to do. So this particular organization, and they are one of our customers, they got like 400 applications, and they actually classified all the applications. They know who are the owners of each of the application. And for these different applications, we know these are the business critical. For them, we do this premium testing on a regular basis during every release. The others, which are less critical, we just do the automated testing or less in-depth testing. So we have a very nice strategy where we have been able to actually reduce their cost of testing significantly while improving their security dramatically. Like we reduce their cost by 50%, going by the conventional ways, and their security posture is at least like 3 to 5 times better, at least going by the vulnerability density. Then the turnaround time, we kind of reduced it to 3 days compared to like 20 days which they had earlier. That's just this testing part. And then what these guys did is they actually created a CQR SDLC. And one thing which I liked about them, and in fact I proposed them as well, was doing it in phases. Like we first introduced a CQR SDLC which is like minimal, a very minimal coding guideline. Then we went to phase 2. So doing it in a very staged manner, introducing CQR SDLC. The other thing which they did was, obviously most of the organizations have a small security team. So initially their bandwidth was getting into a lot of things like testing and talking with their team, etc. So now since we freed a lot of their bandwidth from the testing overhead, now these guys spend a lot of time just coordinating with the right stakeholders, making sure that the patching happens on time. Like this is the most critical element, patching things on time. So now they're able to spend a lot more time in talking with the development team, helping them to patch, explain them better. So they built a very nice patching and patching methodology and software SDLC, secure SDLC, and the way they implemented was like in phases. They never tried this big bang approach. So I think this becomes very important, not just for application security, but this is also from my learning in terms of my entrepreneurship learning. You need to do things in phases. We need not conquer the entire problem in one go. Choosing those right 20% of the things which are going to give you 80% of the result. And that's true even in the next level tactical stuff. Like in secure SDLC, which are those 20% things which you can adopt to get 80% of the result. So they implemented this in a very nice way. So a nice testing methodology, a very nice staggered maturity in SDLC and a patching process, and they recently implemented web application firewall as well. So that's probably a nice example which I can talk about.
That's an excellent answer. And I think that concludes our questions. You might have 1 or 2 slides left, and we'll start to wrap up the webinar.
Hello. I don't know if...
Yeah, so the question, people wanted to know, hey, how do I get my freebies, and what are the freebies? Back to you, sir.
Yeah. So here, we talked about this free penetration testing. So we do have a free penetration testing on our website, but then that doesn't give you the full report. We promise that for the attendees, we'll provide a full report with all the details and a free penetration testing. So you can simply mail to this email address, and we'll revert back with the process on how to avail this. We'll also circulate to you this free checklist to evaluate a pen testing vendor. And also from Gary's side, you got this free e-subscription for the Cyber Defense magazine, which you can try out. And last but not the least, we had this event because of our partner Solantus. We'd like to thank our partner Solantus for helping us to organize this event. And a quick background about Solantus: they're one of the very innovative distributors, and they focus on the cutting-edge new products and new technologies, and they take those solutions to the markets. Alan is a very passionate guy who is very excited about technology and new things. So that's about Solantus. And I'd like to thank all of you for attending this webinar. And this is my email address and my Twitter handle. And this is Gary's email address as well. And thanks a lot. Gary, over to you.
To all of our attendees, we thank you for your participation today.
Prakash, it's been a pleasure. Thank you all for attending. This was wonderful.
Thank you. Have a wonderful day. Because I don't still see them. Yeah.
No, I haven't showed it. You need to do it. What can you see? Including us.